It's a quite big company. I was supposed to show a video, but unfortunately we're not linked to the internet right now. Basically, the message of this slide would be that probably a lot of us are in touch with Mondi, what we say, not knowing, because Mondi is a quite big company. Formerly, we have been a paper and packaging company. Now we are a packaging and paper company, so it's some shift in our strategy. But basically, we deliver a lot of materials, business to business, which are paper-based, but also which are polymer-based. Paper-based, this could be like cement bags, this could be corrugated packaging material. Polymer-based, this would be more the consumer goods packaging, which is all printed material for food packaging applications, for example, but also hygiene components and so on. Yeah, we as Extrusion Coatings, we're a minor segment, I would say, of Mondi, of the Mondi Group. We deal with polymer coating on different kinds of substrates. So we coat, as a standard, for example, paper with LDPE. So we use a lot of standard polymers. I'll come to that a little bit later on. Why are we doing that? Basically, we say we provide barrier. We provide barriers against fire, water, wind, and earth. No, actually we're doing that because we have fire retardant materials, we have materials which are waterproof, we have materials which are put in the soil, so we have a very, very broad spectrum of different applications. We provide those tailor-made barrier solutions for our customer needs. How are we doing this? We have standard polymers, we use biopolymers. Mentioned here are oxo bioadditives, just as one point I would briefly want to discuss with you. This is nothing we really offer in the market. We also have our green range. This means all green products containing like Sustainix. This is a branded material which is compostable, derived from natural sources, but also green PE, where we already heard about today. And we provide those solutions for various industries. So automotive, building, food packaging, medical applications, and polyurethanes, this is slab stock materials, for example. So a very broad area, so I hope at least I cover a little bit of also of your interest. We'll skip, oh, sorry. Green range, Mondi has their own green range, so what we try to define are important points which are relevant for our environment, and how can we achieve like better carbon footprint, less water usage in our paper mills. So all this green thinking is quite important in Mondi, and we have defined like 5 areas where we can see that we can bring a benefit to the environment. First of all, weight reduction, down-gauging, so using less of our resources, try to extend the product shelf life for food packaging, for example. Conserving resources, this is very important for the water consumption, for example. Sustainable forestry, Mondi is still very big in paper producing, but we also have our own forestry in South Africa, and we log quite a lot of wood in Russia, for example, for our certificate plant. So sustainable forestry is very important for us. And last but not least, also biodegradability. And actually, this is the technology we're using. So as said, we extrude polyethylene or other polymers and apply those on the substrate. So it looks like here we have like an unwinding equipment, we have some tension material where we pull it, or pulling station, and this basically is the core of our know-how. We extrude polymers. So what we're doing, we take polymers, we put them in an extruder, we heat them up, we make them like liquid or liquid, and apply those through a dye on the substrate. And then we have quite a lot of possibilities. We have co-extruded, meaning several extruders where we can blend, where we can mix and make all different kinds of things, and also apply a secondary layer on that substrate. And then we have what we call also tandem lines. We have not only one extruder station, but 2 extruder stations where we can build up multi-layer structures in one go. So I don't want to bother you too much with that technology, just showing you that we're really a converting industry. So, normally we use standard LDPEs, polypropylenes, or other crude oil-based polymers, and the chemistry behind is basically that you have crude oil. This crude oil is put into a cracker. You produce like ethylene, and out of this ethylene, this monomer, you produce long chain of polymers, which look on the macroscopic scope like that. So it's long chains which are either amorphous or crystalline, and this also defines the final properties of the polymers. Again, we're using a lot of LDPE, HDPE, polypropylene, all kind of specialities like polyamide, EVOH, EVA, thermoplastic urethanes, which is a big topic for technical application. But all those are normally based on crude oil. Why are we using those polymers? We have a lot of requirements depending on the final application. It can be the heat sealability, printability of the polymer side, its stiffness, it's again the barriers, which are very important, water vapor barrier, oxygen barrier, all that, heat sealability, the processability, that's very important for us because the line I showed previously, they're very dedicated to those LDPE and standard polymers. Naturally, also commercials is important because yes, we would like to sell a lot of environmental friendly solutions, but also that we need a market demand for that. And we offer those materials like now 7-8 years. And still for us it's only a minor share, also due to the fact that commercially they're not so interesting yet. Why? Because people only see the price as such. And this is what we try to discuss with our partners. It's not only the price, it's an added value product, and they really have to embrace that thinking because otherwise it will be very, very hard to show them the advantages of biopolymers and then some other mechanical properties. I think we also had a definition of the biopolymers, so either they're bio-based on renewable sources and or biodegradable. So in the consequence, not every biopolymer from renewable sources is compostable, and not every compostable biopolymer is derived from natural sources. But I think my Swedish is very, very bad. I think "tack" is the only word I know, but I think you explained this quite good and quite extensively. So, okay, then I can skip that. I think this picture is quite similar to yours, so I can skip that. I think just 1 minute on that transparency, where we see a tendency, which is very interesting. So we start in the volumes of biopolymers, still on a quite low level, but European Bioplastics, they expect really a big growth in the usage and the conversion of biopolymers. Biopolymers really biodegradable, but also like the green PV from FQ. And so we really see a tremendous increase in the usage of those polymers. Yeah, the majority of the commercial available bioplastics is already bio-based, non-biodegradable, so the FQ material, for example. And the share of non-biodegradable polymers is expected even to grow. So this is something, again, European Plastics prognosis or sees for the future, that like green PE the proportion is growing and growing a little bit higher compared to the biopolymers derived from natural sources which are compostable. Good. A short scheme, why are we doing this? Biopolymer materials which are compostable, because we think that we really can have closed loop in the usage of material. So derived from natural sources, we can build up like coated materials. We produce these in Mondi, for example, into bags. We have a waste collection system. The materials are then biodegraded. We have humus, and then we can build up wood again or other polymers, and then we really have this closed loop. Our materials are normally either aerobic biodegraded or anaerobic biodegraded, and I like your presentation a lot about this anaerobic biodegradation because it's getting more and more popular, especially in Germany. A lot of the municipalities, they invest a lot of money in that, and those communes are really interested in increasing the share of waste collected. You brought the example of the waste collection bag for the green cut. This is a project we're targeting together. The Nespresso is something different, but this is very interesting because really we have now these big biogas facilities. They have a lot of capacities, and the communes, they want to fill those capacities. And we can help increasing the share of either kitchen waste collected or green cut waste collected. Bioplastic, I mentioned this only briefly because we already have a little bit of confusion, biodegradable, non-biodegradable, renewable sources, non-renewable sources. On top there are so-called oxo-bio additives. Those are materials like mass batches which are incorporated into LDP, for example, or polypropylene. What happens when, this is extruded or coated, for example, you have the plastic material then, and once they're in contact with UV light, humidity, and temperature, those materials decompose, they're degraded. And this is proven, and those materials are often used when littering is a problem. The problem is for us, as Mondi, for example, the degradation process, it's not proven. So you have the degradation to very small particles, what they also call the nanoplastics, but we are not sure that from the nanomaterial on, there is a biodegradable process by a microorganism. So that's the reason we are quite reluctant using those materials. They are in use in some countries, for example, in Asia, for example, where they have littering issues. But again, Mondi is not really promoting those materials. And on top, there's no European norm really saying that the material is biodegradable. And this is one thing not mentioned so much up to now, but I think we have to be very careful with claiming things like biodegradable, with composting and so on. Because in Germany, for example, there are institutes, public institutes, they look quite into the detail if your claims on the product are right, are they in line with the legislations or not. And this is also one thing we discovered when talking to a customer, that we have to teach them a lot about the norms, what they have to take care of to really get the most benefit out of using biopolymers. Bioplastics capacities, it's increasing. This is also in line with what I showed previously, and I have to skip some transparency because I think I'm running out of time a little bit. It's only showing basically that the capacities is increasing quite tremendously. This is also in line what you could see previously, that the demand and the production will more than triple over the next years. Now I'm coming to our sustainability range. Biopolymers address different topics depending on the type of bioplastic. Sustainability, so then it's the use of renewable sources to reduce the carbon footprint, for example. We can also address recycling issues. We can address the biodegradation, either industrial composting and home composting, whereas I have to mention we don't have really home composted materials because the demand for us is very low, and people are also reluctant putting this into home or packaging materials, for example, into their home compostings. And there's some technical issues we have to address, like barrier properties. If you have food material which should be packed, then we have to talk about barrier properties like oxygen. We're talking about mineral oils, components from recycled board, for example, which can migrate into foodstuff, which can be harmful for human beings. We talk about grease barriers. This could be an important topic, for example, if we look at materials from fast food chains, if you have this coated board, for example, for your hamburger. We talk about barriers against liquids. Cup stock is a very good example. And as water vapor barrier is not so good for many of the biopolymers, we prefer talking about breathability, because then we try to make an advantage out of this obvious disadvantage of some of the biopolymers. Because for some products they should have some kind of breathability, and this is what we can deliver with biopolymers. I mentioned the legislation. There's another topic which is discussed quite intensively. So we had some 2 years ago the discussion about bioethanol for the gasoline for the cars, to fuel the cars. And there we had a discussion. We have the competition, food against fuel, for example. We have the same discussion for biopolymers. Is there really a competition between foodstuff and biopolymers? Honestly, the volume used for producing biopolymers is actually neglectable. It's very, very small. And as you know, maybe, I think 50% of the starch production are already used in industrial applications. But nobody likes to talk about it, especially in Mondi, because it's mainly paper and used as fillers. So food stuff is already used in industrial application, And the content which is used then for biopolymers, it's like 0.01% or assumed 0.02% in 2017. So this is, again, negligible compared to all the other uses, also in industrial applications. What is the driver for using biopolymers? It supports your sustainable, eco-friendly brand image. It's some kind of differentiation on the market. It can reduce the carbon footprint, also something which has to be discussed in detail. We can use renewable sources, either for the green PE or also for like the EcoView material, which are based on renewable sources. We can improve the end-of-life scenario. And I think this is one of the big advantages of biopolymers when they are compostable, that you can either use it in combination with the foodstuff, if you talk about food packaging, and you can waste them together. For retailers, this could be quite important. I just think about sandwiches. A lot of this over-the-counter sale of sandwiches is in a coated board. Once the shelf life expired, you have to separate the waste from the foodstuff. If you use a biopolymer-coated tape, for example, all components are compostable. You can use all of them in a biogas facility, for example. And there are some technical advantages, again, like this breathability. Our Mondi solutions, we have Sustainix. This is a biopolymer based on renewable sources, which is compostable. It is food safe. It is compostable according to the EN 13432. Home composting, unfortunately not. I don't know why it's mentioned here. And you can see one example outside. This is the espresso bag. And then we have LDPE from renewable sources like green PE. It's again based on renewable sources, not compostable, and we use it partly for food application. If you ask me now from the technical perspective, what's the advantages and disadvantages of those materials? So you see we have a lot of experience using LDPEs, and the efficiency using those materials is very high in our lines. So from the technical point of view, those materials are quite easy to convert. For us, it's more challenging to use those biodegradable material because we apply quite high temperatures in our process, like 300 degrees plus. So this can destroy already the biopolymers. So we have to go down in temperature. This costs OEE. We have some discussions. So we like challenges. We can handle this, but I just wanted to point out that also those materials, they have some benefits from the converting point of view. Yeah, our Sustainix biodegradable range. It's biodegradable, renewable sources, approved for direct food contact, fully compliant with international accepted standards, which the oxo-bios are not, and eligible for organic recovery, composting, anaerobic digestion, and energy recovery. This is the example we are allowed to show, and for us it's a quite big success story because we have a big partner behind. And this is one of the applications where the use of biopolymers actually makes a lot of sense, because we have this biopolymer coated bag, which is watertight, so you can collect all the Nespresso capsules in it, you bring it back into the store, they bring it to a recycling facility, aluminium is separated, it's reused, and then you have the grounded coffee, plus this compostable bag. This is going into a bioplant, a biogas facility, so you have the energy recovery of the gas, plus a cascade later on, you have composting attached to that, so what you mentioned is cascade use of our materials. And those are the benefits we see for our customer. So biodegradable, compostable solution, we have good mechanical strength, good sealability, high printability, we have again the ecological thinking, we have grease water barriers, and the eco-friendly brand image. Green PE, renewable sources, reduced carbon footprint. Same properties as standard PE. This is very important for some of our customers because they don't have to make a new shelf life test because it's practically the material they already know, but now from renewable sources. We have this long shelf life, we have this carbon dioxide capturing mentioned already, we have the chemical resistance, and we have a higher price range compared to standard, but still moderate compared to some of the biopolymers which are biodegradable. Yeah, and this is our message, go green with Mondi extrusion coating. I think Mondi as such, we have quite good recognition for our sustainable performance. We do a lot also on the paper side. We care about our sustainable resources and our products. And what we would like to do with you, develop those tailor-made sustainable solutions for the customers. Again, it's not like selling standard products. It's a lot of discussions. It's a lot of discussion with marketing to really show you the benefits, that not at the end of the day you have an expensive product and no added value you can show. And we want you to go green with us. Thanks a lot for your attention.